Every single skeleton has a story to tell. It's like a biography, written right there in the bone, a record of a life. Experts actually have a name for this, an osteobiography. And today, we're going to learn how to read one of its most important chapters, using the skull.
So how do they actually do it? How does a forensic expert take a skull with no name and no history and start to figure out who that person was? All right, let's get into it. We're going to treat this just like a detective story, and the skull, that's our #1 clue. The very first step in building this biological profile, this osteobiography, is usually figuring out the individual's sex. Now, why start there? It's simple, really. It immediately cuts the search for a missing person in half. It's the foundational piece of the puzzle that everything else gets built on. But how accurate is this really? I mean, we're just looking at a bone. Well, with a complete skull, experts can be right about 92% of the time. That is incredibly reliable, one of the best tools they've got. But that other 8%, that's where things get really challenging and, honestly, super interesting. Okay, so the investigation kicks off with a good old-fashioned visual inspection. An expert is looking for really specific traits, these telltale signs that show the physical differences between males and females. These differences really start to pop after all the hormonal changes during puberty, so let's look at the big ones, side by side.
First up, the brow ridge. Now just look at the difference here. On the left, you see a typical male skull. It has this rugged, prominent, almost shelf-like piece of bone right above the eyes. You can just feel how solid that is. Now compare that to the female skull on the right. It's generally much smoother, what experts call gracile, and it makes the whole forehead look more vertical.
Next up is the mastoid process. Go ahead and feel that bony lump right behind your own earlobe. See, in males, this spot tends to be a pretty large, blunt anchor for some heavy-duty neck muscles. But in females, as you can see, it's usually smaller and comes to more of a point. It's a subtle clue, but a really important one.
And then there's the jaw, the mandible. The male jaw is typically bigger, thicker, and the chin is more squared off, creating this classic U shape. The female mandible, on the other hand, is usually smaller, and the chin is more rounded or even pointed, giving it more of a V shape.
So with all these clear visual markers, you'd think this would be pretty straightforward, right? A quick checklist and you're done. Well, not quite. The reality is, these traits don't just fall into two neat little boxes. They exist on a spectrum.
Yeah, it's definitely not always a simple case of male versus female. The truth is, many people have a mix of these traits. Nature doesn't really do perfect binaries, and human skeletons are a perfect example of that. This biological overlap is one of the biggest challenges for forensic experts.
To handle all this gray area, experts use a standardized scoring system, like this one from Buekstra and Ubelaker. They look at each feature and rate it on a scale from 1, which is definitely female, to 5, definitely male. And here's the kicker. A whole lot of skulls score a 3, landing smack dab in that ambiguous middle. It's a perfect reflection of that biological continuum.
So what happens when the visual clues just aren't clear and a skull scores a 3? Well, investigators can't just flip a coin. They need objective, hard data. And that's when they call for backup from technology.
And this is it. Meet the digital detective, Fordisk. It's a seriously powerful software program that does something called metric analysis. So instead of just looking, investigators take a whole bunch of precise measurements of the skull and plug them into the program. Fordisk then compares those numbers to a massive database of measurements from populations all over the world. So why go through all that trouble? Because of this number, 95%. In a legal setting, for any piece of evidence to be considered reliable enough to present in a court of law, it has to hit this minimum threshold of certainty. And tools like Fordisk are what help experts get there when the bones themselves are a little ambiguous.
So, we have the expert's visual analysis, and we've got powerful software. That should have us covered, right? Well, there are still some known limitations. And one final, really surprising twist that can make this job even harder.
I mean, there are some well-known challenges. For example, it's almost impossible to determine the sex of a kid's skeleton because those key traits just haven't developed yet. And as we said, the math used in software like Fordisk has to be specific to a person's ancestry because traits vary across different populations. And of course, you've always got that natural biological overlap.
But here's a wild thought. What if the evidence isn't a fixed thing? What if the story that's written in the bone can actually change during a person's life?
And here it is, the final twist in our story. It's called the aging effect. Get this. Research has shown that as women age, especially after menopause, the hormonal shifts can actually cause the skull to develop traits that look more masculine. The brow ridge might get a little more prominent, muscle attachments can get bigger. A skull that might have looked clearly female at age 30 could look a lot more ambiguous by age 70, making things tricky for even the top experts.
So what's the big takeaway here? Reading a skull is an incredibly complex and nuanced science. It's not a simple checklist. The best investigators have to combine everything: a sharp eye for those visual traits, the incredible power of statistical analysis, and a really deep understanding of how things like ancestry, and even just the process of aging itself, can shape the final chapter of the story written in our bones.